Good day friends, welcome back. Today we're going to learn how to use complete enumeration method and Dijkstra's algorithm to find out the shortest path problem to a given network. For this we consider the same network which we had seen in the formulation of the shortest path problem in the form of linear integer programming problem. This is the network that I have. In this network I have a total of 7 vertices and 12 connections. To apply the complete enumeration method in this particular network to find out the shortest path from S to T, we need to construct a table. The number of columns in the table will be decided by the number of vertices. Since we have 7 vertices over here, we are going to have 7 columns in the table. The entry in these columns are nothing but the connection of the vertices to the remaining vertices of the network. So from S you have 3 connections, SA, SB and SC, and the entries are going to be done on the basis of the ascending order of the distances of these connections. Since in this tree connection SA has the least value, this will be entered first, and SB has the highest value, and this will be entered at the end. We also have seen in the while doing the formulation that from S you can only move out, coming back to the S was not allowed. As for T, only moving inside or moving towards T was allowed, and moving out of the T was not allowed. Now, so when you look into A, you have a total of 3 connections, but this connection from A to S will not be allowed because you are going to move from to the starting node. This is not allowed. So you're left with only 2 connections. Of these 2 connections, AD has a higher value and AB has a lower value. So AB will be entered first and followed by AD. Similarly, you fill up the remaining columns of the table. The T column will be leaving the T column blank because you don't have any connections from T to the other nodes. So once this is done, you can start finding out the shortest distance from S to T. To find out the shortest distance from S to T, we need to construct a tree, which we call it a distance tree. The first node of the distance tree will be the starting node. You are going to start from S. So you are at S, you are at 0 distance. S, you're at 0 distance. Now, next, what you do is, let us start constructing a distance tree, right? A distance tree. So to construct a distance tree, let me draw a circle. This is the first node. So this is the first node of the tree. So to start with, you have a single node in the tree. From this node, you will try to reach out to the other nodes of the network. So the reaching out to the other nodes of the network will be done on the basis of the connection given in this column. The nearest node to S is A. So the next node of the tree will be the node number A. With a distance of 2 plus 0, which is 2. You will be reaching from S to A. Let me color this one. This node has been used. Right. So you are connecting from S to A. This is going to be your A. Right. So what I'll do is I'll connect this 2 nodes. From S you have gone to A with a distance of 2. Now the current tree has 2 nodes, S and A. From these 2 tree nodes, we'll try to reach out to the remaining nodes of the network. And this again will be done using the connections given over here. So what I'll do is I'll check if you go from S, then the best option is C with a distance of 4. If you go from A, then the best option will be B with a distance of 2 plus 2. Remember, the distances are always going to be measured from the starting node. So 2 plus 2 is 4, you can go to B, and 0 plus 4 is 4, you can go to C. Let me select this option. So I'm moving from S to C with a distance of 4. S to C with a distance of 4. with the distance of 4, right? See, if you have any combinations of A and C in the table, that has to be crossed out. That cannot be considered for any further connections. If you don't cross out, then you will end up forming a loop. This formation of a loop in the tree nodes is not allowed. So any combination of tree nodes in the table, if any, you will have to cross it out, right? Since you don't have any combination of A and C in the table, you don't need to cross it out. Now, the current tree has 3 nodes. From these three nodes, you'll try to resort to the remaining nodes of the network. You look, if you try to resort from A, you can go to B with a distance of 5. If you try to resort from A, you can go to B again with a distance of 4. If you try to resort from C, you can go to B again with a distance of 4 plus 1, which is 5. So the best option is to go from A to B with a distance of 4, right? With a distance of 4. A to B with a distance of A to B with a distance of with a distance of 4. A to B with a distance of 4. Now let's check for the possible combinations of tree nodes. If you have BC, AC, that has to be crossed out. Yes, BC and AC are there. This has to be crossed out. This crossing out has to be done simultaneously, otherwise you will end up forming a loop which is not allowed. Now the current tree nodes are S, A, B, and C. You will try to resort to the remaining nodes of the network with the current tree nodes. With the current tree nodes, right? With the current tree nodes. So if you go from A, then you can go to D with a distance of 2 plus 7, which is 9. If you go from B, then you can go to E with a distance of 7. Then from C to E is 8. So this is the better option, right? So we're going from B to E with a distance of 7, right? So B to E, this also has to be color. So you have moved from B to B to E, B to E. B to E. Now let us cross out all the possible combination of tree nodes from the from the table. EC is there. This has to be crossed out, and DEC and its CE also has to be crossed out, right? So you are left with the combination of D and the T only in the table, right? Now let's try to go to D and T from the tree nodes. So if you go from A to D is 9, from D to D, if you go from B to D it's 8, from B to D, E to D also it's 8. A to D is 9, 8. This is 8, I think. Okay, can go from B to D, 8. B to D is 8, and DB also will be color 8, right? B to D is 8. B to D is 8. Yeah, this 8 is not, this 8 is measured from S, not from B. So again, crossing out, DA will be crossed out, AD also will be crossed out, DE will be crossed out, and the ED also will be crossed out. So what is the next option? The next option is to go from, if you go from D to T is 13, if you go from E to T is 14, so you go from D to T. D to T is 13, right? 13, 13, 13, this is 13. D to T is 13. D to T is 13. No, I think you have to find a part. This 13 again, let me repeat, this 13 is measured from S. This, I forgot to color it. This would have been color red. So everything is now color. Now I think you have the part, you have the shortest part now. The shortest part is from S to A, from A to B, from then B to D, and finally from D to T, and with a total distance of 13. Let's check it from the network. You grow from S to A is 2, then from A to B is 2, 4, 4 plus, from B to D is from B to D is from B to D is 7, then from B to D, sorry, B to D is 8, 8 plus 5 is 13. 2, 2, 4, 4 plus 4, 8, 8 plus 5 is 13. So this is how you find out the shortest path using complete enumeration technique, right? Complete enumeration technique. Sorry, let me make it a little bigger. This is the part that we're following. This is the part that we're following, and the total distance on this part is 14, and you can verify this from the network also. And this is how we use complete enumeration method to find out the shortest path to any given network. Thank you very much. We'll see how Dijkstra's method work in the next video. Thank you.